Welcome to part 3 of the entrance exam questions. This is the Kerala Engineering Entrance Exams questions, and let's jump to question number 29. A point-to-point communication mode is seen in which one of these? Satellite cable communication. Of course, satellite cable communication is not point-to-point. Television, FM, AM, all of these are broadcast networks where from one you broadcast to many. From one to many. Point to point means from one to another one. And so the answer would be fax transmission, because fax goes from one person to another person, not from one to many. So that's the answer to that question. So there are two types, point-to-point. Fax is obviously point-to-point, and the others are point-to-multipoint. From one point to many points. That's also called the broadcast network. Right. Number 30. If the heights of transmitting and receiving antennas are each equal to h, the maximum line of sight distance between them is how much? R is the radius of the Earth. So let's look at the diagram. So that's the surface of the Earth. That is the radius of the Earth. And that's the point where you have one antenna right there. And then at that other point, you have the second antenna. So here is one antenna, the second, and that is the line of sight. You see, that means you can see from one directly to the other. So that's why it's called line of sight. So this would be h, the radius would be r, which is the radius of the Earth. And then from that geometric diagram there, you see the triangle. We can see that is r. This is also the radius of the Earth. This is r minus h, because this is r, correct? That is the radius of the Earth. But this is h. So the remaining distance should be r minus h, will give you that much. So now you have a right angle triangle here where you can apply the Pythagorean Theorem. So let me take that as d. That's the distance. Of course, d is the distance from the midpoint to where the antenna is. So if that's d, then when you apply the theorem, you would get d squared is equal to r squared minus r minus h whole squared. And then you have to expand this. So that would be r squared minus, this would become r squared minus 2rh plus h squared, correct? And then after that, we'll have to distribute this negative sign, which will make all this negative. That means all the signs will change. When the signs change, it becomes, easy to see that the r squareds will get cancelled because you have plus r squared minus r squared. And then when you look at it, you have 2rh minus h squared. But then remember, r is the radius of the Earth, which is really big. It's about 6,400 kilometers. And h is, you're going to get a very small quantity. That means this h squared is negligible compared to 2rh. So when you neglect that, you're going to get d squared is approximately equal to 2rh, from which you get d is equal to square root of 2rh. So the line of distance AB. So that's AB. So AB should be 2 times that. So you're going to get 2 times square root of 2rh, which actually is square root 8rh. Because if you take this 2 inside, you'll have to put it as 4, right? So that's the answer. The next question, the ionospheric layer acts as a reflector for the frequency range. Okay, this is information that we need to know. The ionosphere acts as a reflector. So when you send the radio waves from the Earth, it hits the layer and is reflected back to the Earth. So that's how radio broadcasting was done before the satellite age. It's still being used. But instead of the ionosphere, now you have a satellite which will pick up any frequency and broadcast it. But when we were using the ionosphere, or when we use the ionosphere, it's only this particular range of frequencies that are reflected, which is 3 to 30 megahertz. So we need to know that. All right, so 32. In a simple pendulum experiment, the maximum percentage error in the measurement of length is 2%, and that in the observation of the time period is 3%. Then the maximum percentage error in determination of the acceleration due to gravity, g, is. So this is quite often a repeated question, and we have to use the formula in order to find out the percentage error. In this case, it's the time period of the simple pendulum. And the time period of the pendulum is given by t is equal to 2 pi square root of L by g. And since we are trying to find the percentage error in gravity, acceleration due to gravity, we will make that the subject. But first we square it, so we get rid of the square root in the step, and then you get g is 4 pi squared L by t squared. Therefore, delta g by g, which is the error, must be delta L by L plus 2 times delta t by t. Why? Whenever you calculate the error, you can disregard the constant because they don't change. So there's nothing there. So that's why 4 pi squared is gone. And then L is in the numerator, so it will be del L by L. But t squared is in the denominator, see? So whether it's in the denominator or the numerator, the next one is going to be plus. But because it's t squared, it becomes 2 times delta t by t. If it was something like t cube, then it will become 3 times that quantity, okay? So here it's 2 times delta t by t. So we given that the percentage error in the length is 2, and that in time is 3. So when you do this, you get 8. So 8% would be the error. That is the answer, okay? Next is the pitch and the number of circular scale divisions in a screw gauge with least count 0.02 millimeter are respectively. So this is about the least count of a micrometer screw gauge. We have to know that the least count, which is the smallest distance that can be measured using this instrument, is given by pitch divided by number of divisions on the head scale. So pitch divided by number of divisions. So let me write that. So least count is pitch divided by number of divisions. In this case, the least count is given, but we have to figure out the other two. So we will work with combinations, and when you take the pitch, there's only one combination that's going to make sense for you to get 0.02, and that is this one. 1 millimeter divided by 50. 1 divided by 50 is going to give you 0.02 millimeters. No other combination will work. For example, the first one would give you 1 divided by 100, which is 0.01. B would be, say, 0.5 by 50, which is 1 by 100, so 0.1. And D would be 0.5 by 100, which is 0.05. 1 divided by 2. So you see that only C works. So that is the answer. 34. This is from kinematics. A ball is dropped from the top of a tower of height 100 meters. Okay, a ball is dropped. Initial velocity is 0. And at the same time, another ball is projected vertically upwards from the ground with a velocity 25 meters per second. So one ball is dropped, the other ball is thrown vertically upwards at 25. So they are going to meet somewhere. Then the distance from the top of the tower at which the two balls meet. So where are they going to meet? Let's imagine that they meet x distance from the top. So if this is x, see, this is going to be 100 minus x because the total is 100, right? The total is 100. This is x. The remaining should be 100 minus x. So let me show you the diagram. So that is the tower. The ball is dropped from there. This ball is thrown up, and this is where they meet. This is taken as x, so this would be 100 minus x. So when you use the kinematics formula for the first object, we know its initial velocity is 0. The acceleration is the acceleration due to gravity. And we can calculate delta x. We can have an equation, which is v naught t plus 1/2 at squared. Now v naught is 0, so the whole thing becomes 0. So we get x is equal to, or delta x is equal to 1/2 times 9.8 times t squared. 1/2 times 9.8 is 4.9. So we get x is 4.9 t squared. That makes sense, right? Now for the second object, when we try to write a similar formula, remember that is 100 minus x. When you write a similar formula, you would get 100 minus x, because the displacement is 100 minus x, is equal to 25t minus 4.9 t squared. That makes sense? 100 minus x is equal to 25t minus 4.9 t squared. So when you solve that, you can see that in place of 4.9 t squared, I can substitute x. That's what I did. And then you get t as 4 seconds. And then you can plug that value of t back into this to get x. So x would be 4.9 times 4 squared, which is 78.4. Now some of you may have noticed that I'm not using negative 9.8. It won't make a difference, because if you take this as negative, you have to take this also as negative, see? Because it's going down. So two negatives make it a positive. And in this case, 100 minus x is going up. It's going to be positive. And then I've already taken this as negative. So hopefully you understood that even if I don't take a negative here, that's the same thing. Because I put a negative here and I put a negative here, cancels out. I hope you got that. So that's how we do that problem. 35. The ratio of distances traversed in successive intervals of time when a body falls freely under gravity from a certain height. So when you drop an object from rest, in 1 second, how much does it travel? The initial velocity is 0. So 1 second, it travels 1/2 times 9.8 times 1 squared, which will give you 4.9 meter, right? Let me show you. All freely falling objects in the first second will fall through 4.9 meters. Okay, here it is. So delta x, once again, if you take g as negative 9.8, you're going to get negative 4.9. It just shows that it is going down. So in t is equal to 1, you get half a. But what about if t is 2? In 2 seconds, how much will it travel? From the beginning. So v naught again is 0. So in 2 seconds, it will travel half a times 4 minus 1. Okay, what am I doing there? Because 2 squared becomes 4, right? So in 2 seconds, it's going to travel 2 times half a times 4, but it has already traveled something in the first second. Now you got the total. So to find out how much it traveled in the second, you will have to subtract the total minus what it traveled in the first second. Are you with me? Total minus what it traveled in the first second. That's why I subtracted 1. So you're going to get 3 times half a. Now in the third second, same thing. In the third second, t squared is now 3 squared, so that becomes 9. But then you'll have to subtract, not 9 minus 1, but 9 minus 4, because you have to subtract the distance in 2 seconds. So now you can see that the ratio is 1:3:5, but I'm also going to give you numbers So it makes it clear. So in 1 second, it's 4.9 meter. In 2 seconds, it's 14.7 meter. And in 3 seconds, it is going to be 24.5 meter. So you see that? The diagram should make it clear. It travels 4.9 meter in the first second, 14.7 in the next second, 24.5 in the third second. The total displacement in 3 seconds is 44.1. The total displacement in 2 seconds is 19.6. Hope that makes sense. Thank you. Here is the next one. A particle starting with a certain initial velocity and uniform acceleration covers a distance of 12 meters in first 3 seconds and a distance of 30 meters in the next 3 seconds. What is the initial velocity of the particle? So a particle starting with a certain initial velocity. So we do not know the initial velocity. We know it has a uniform acceleration, but the acceleration is not given. So we don't have the initial velocity. We don't have the acceleration. We know that it covers a distance of 12 meters in the first 3 seconds. So we can use a kinematic equation and get one equation for that. And then it covers a distance of 30 meters in the next 3 seconds. We'll come to that. First, let's take the first one. Okay. Let me just show you how I did that. Delta x is v naught t plus 1/2 at squared is the equation that I'm using. So we know 12 is equal to, because it travels 12 meters, 12 is equal to 3 v naught, because t is 3 seconds, so 3 times v naught plus 1/2 times a times 3 squared. 3 squared is 9. 9 divided by 2 is 4.5. So that's how I got that equation. Then, next when you consider the total time of 6 seconds, because it's first 3, next 3, total time of 6 seconds, how much did it travel? 42 meters. That's right. 12 plus 30. 42 meters in 6 seconds. Because we can only use the total displacement in this equation. So that's why I'm doing that. 12 plus 30. You see the 6 is the time. Plus, now how did I get 18? 6 squared is 36. 36 divided by 2 is 18. So I got my second equation. So the first one and the second one. And in order to solve it, you know what I did? I just said, let's multiply the first equation with 4. All right? You multiply the first with 4, and then you subtract this one from this. Let me show you. This will become 48 minus this is 42. So that's why you have 48 minus 42. And then here you have 12 V naught minus 6 V naught. See? And then this term, 4 times 4.5 is 18. So 18a minus 18a is 0. So my aim in multiplying this with 4 was to get rid of the term with acceleration in it. Okay? So once you do that, now it's easy. From the right side, it's 6 V naught. 12 minus 6 is 6. 48 minus 42 is 6. So V naught is 1 meter per second. So if you didn't like the way I did it, you can solve it by substitution or another form of elimination, whatever you like, but that's how you get the answer. 37. A ball of mass 10 gram moving perpendicular to the plane of the wall. So that's the wall, and this ball is moving perpendicular to the plane of the wall, strikes it and rebounds, so comes back in the same line with the same velocity. Notice that? So that's velocity 1, that is positive. This velocity is the same in number, but it's negative because the direction changed. So that's what some students forget. Never forget that. If the impulse experienced by the wall is 0.54 Newton second, what is the velocity of the ball? So now you have to know what is impulse. Impulse is change in momentum. impulse is change in momentum. So what is momentum? Momentum is mass times velocity. So it had mv this way, and then coming back it had negative mv. What is the change? It's not zero, because mv minus of minus mv makes it mv plus mv. That makes it 2m times the velocity. Okay, instead of writing in air, let me show you. So J is the symbol for impulse. That is mass into V final minus V initial. That is the formula. And in this case, the velocities are the same. So impulse is 0.54. Mass is 10 gram. 10 gram is 0.01 kilogram. And then I take the final velocity. If I take the final as positive, then the negative would be negative. Then the initial would be negative. If you take the final velocity as positive, the initial would be negative. You can do it either way. Just make one of them negative. So in this case, you see minus of minus, initial velocity makes that positive. Okay. And so now I get 0.01 multiplied by 2 times that velocity. Then solve for velocity, and you would get 27 meter per second is the velocity of the ball. Okay, that's the diagram. See that? Look at how the velocities change direction. So that is very important for you to understand. All right, so there is 38 now. A particle has the position vector r is equal to I minus 2j plus k, and the linear momentum vector p is 2i minus j plus k. It's angular momentum. So you're given position vector and you're given the linear momentum, and you have to find the angular momentum. How do you do that? Angular momentum is the cross product of r and p. So now we have to know how to take the cross product. Angular momentum, L, is the cross product of R and P. There's supposed to be a vector here, okay? And then what you do is you put I, J, K, and then list the coefficients. Let me slow this down. 1, minus 2, and 1. Where did I get that from? That is 1 here, minus 2, and 1. And for P, I have 2, minus 1, and 1. So I just listed the coefficients of both of them. And now you have to take the cross product. To take the cross product, to get the coefficient of I, don't look at it, what is below that. Just look at this. Minus 2 times 1 minus 1 times minus 1. So minus 2 times 1 minus 1 times minus 1. So that's how you get the coefficient of I. Now for j, don't look at these. Do the same thing, but put minus j and then go 1 times 1 minus 1 times 2. Okay, for k, same thing. Don't look at these. Go plus k, 1 times minus 1 minus minus 2 times 2. So when you do that, let's see what you get. For I, it's minus 2 times 1 minus 1 times minus 1. That gives minus 1. And then j, minus j times negative 1 plus k. K, remember 1 times minus 1? That's minus 1 plus 4, so you get 3. That means when you rearrange, you get negative I, negative j, plus 3k. So that is how we do it. That's how you get the answer. That is the answer. All right, the next one. The vertical component of velocity of a projectile at its maximum height. That is a trick. See, when you project it, it has a horizontal component and a vertical component. But the important thing is to remember that the horizontal component never changes. The horizontal component is a constant. Because it's horizontal, gravitational force will not act on it because gravitational force is vertical. So the horizontal velocity never changes, but the vertical component starts out with a maximum, keeps decreasing as you go up, and becomes zero at the highest point, and then it begins increasing again, but in the opposite direction. See that? So the vertical component continuously changes. This question is saying, what is the vertical component at its maximum height? It is zero. At its maximum height, the vertical component is zero. Here's the next one. The coordinates of a particle moving in xy plane at any instant of time t. So there is a particle moving in an xy plane, that is two-dimensional motion. And at t, x is 4t squared, y is 3t squared. Find the speed of the particle at that instant. How do you find speed from the position coordinates? You have to take the derivative of the function with time. So that's what we're going to do here. So x is 4t squared, from which Vx, velocity along the x, is d by dt of 4t squared. I hope you know how to do that. This becomes 2t when you do that. So 4 times 2 is 8t. Same thing, y is 3t squared, so Vy is d by dt of 3t squared. Again, this is 2t, 3 times 2 is 6. So you get 6t. So you got the velocity along the x, you got the velocity along the y. Now you have to find the speed, which is the magnitude of the velocity, for which you have to use the Pythagorean Theorem, which is 64t squared, because you're squaring both and adding them, taking the square root. 8 squared, 64. This is 36. And then when you add this, you get 100t squared. Square root of 100 is 10. Square root of t squared is t. That's how we get 10t as the answer. All right. 41. A cyclist bends while taking a turn in order to, why does, on a straight road, the cyclist is vertical. But when taking a turn, maybe a left-hand turn, the cyclist bends from the vertical. Why? Because the cyclist is trying to provide a centripetal force. Because whenever a particle goes around in a circle, it must have a centripetal force to keep going around the circle. Otherwise, by Newton's law, it'll go straight. It'll keep going straight. That's why the cyclist bends. So the answer is to provide the required centripetal force. I'm trying to show you the free body diagram. The weight of that cycle and the person is mg. N is the normal reaction. F is the vector sum of n and the centripetal force. So you see, if this person does not incline, there is not going to be this force. There will be no centripetal force. Hope it makes sense, does it? All right. Let's see. Let's go to the next one. 42. Interesting. You have two objects tied to each other. Two objects or bodies of masses 2 kilogram and 4 kilogram are attached by an inextensible light string as shown in the figure. Okay? So you have 4 kilogram up, 2 kilogram down. They are tied by a string. And a force of 120 Newton pulls the blocks vertically upward. You pull it. So you're applying the force on the upper block, 120 Newton. The tension in the string. So we have to find the tension in the string attached between the two masses. Okay? So in your head, you should be able to separate these two objects. That's why it's called a free body diagram. So when we look at the first object, which is the 4 kilogram object, what are the forces acting on the 4 kilogram object? You have the 120 Newton, yes. Then you have the weight of the 4 kilogram. second force. And then what do you have? You also have the tension in the string. So there are three forces acting on the 4 kilogram. Again, 120 Newton, the weight of 4 kilogram, and the tension in that string, Ft. But when you look at the 2 kilogram, there are only two forces acting on it. What are those two forces? Now, don't worry about the 4 kilogram. We're only looking at the forces on the 2 kilogram. What are they? One is the weight of the 2 kilogram. The other is the tension. See that? So we will use this free body diagram and use Newton's second law. Let me show you how we do that. Okay. I'm showing the forces. 120 Newton. That's on the 4 kilogram. Ft and 4 times 9.8. That's the weight. How do you find the weight of an object? Mass times acceleration due to gravity. That gives 39.2 newtons. Those are the forces on the 4 kilogram. Now on the 2 kilogram, you have two forces. What are they? One is Ft, and then you have the weight of the 2 kilogram, which is 2 times 9.8. So you may have noticed that Ft acts down and Ft also acts up. Yes. Now when you look at the 4 kilogram, the net force, what is the net force? Up is taken as positive, down is negative. So 120 minus Ft minus 39.2. That's the net force. 120 minus Ft minus 39.2. And net force must be equal to mass times acceleration. The mass of that object is 4, so 4 times A, because we do not know A, okay? So when you rearrange that, you're going to get Ft is equal to 80.8, because 120 minus 39.2 gives 80.8. All of these two equations, first, from this equation, Ft plus 4A is 80.8. Is that clear? Ft plus 4A is 80.8. Then we look at the second object, and their net force is Ft minus 19.6. So Ft minus 19.6 should be equal to 2 times A. So Ft minus 2A is equal to 19.6. All right, that's equation 1, that's equation 2. Perfectly set up. I want to cancel the A terms. So what I do is I multiply this with 2. See, multiply this with 2. And then this will give me negative 4A. Here you have 4A. So if I add the two equations, the A term will get cancelled. So then I'll be left with 2Ft here plus Ft, which is 3Ft. And then I have 2 times 19.6 plus 80.8, which gives 120. So 3Ft is 120, and so Ft is 40 Newton. This is another way of solving it. I just wanted you to see this is faster because you did not have to find acceleration first. Either way, the idea is to draw the free body diagrams and then eliminate whatever you don't need and calculate the value of what you're asked to calculate. Okay? All right, so number 43. The total energy of a solid sphere of mass 300 gram, which rolls without slipping with a constant velocity of 5 meters per second along a straight line. So you have a solid sphere and it's rolling. So when it's rolling, there are two types of motion here. One, it's rotating. Two, the center is moving in a straight line. So whenever the sphere rolls, it has rotational kinetic energy and linear kinetic energy. It has both kinetic energies. So to find the total energy, we have to add both of them. So let me give you the equations. The total energy of this, total energy is rotational kinetic energy plus translational kinetic energy. Translational means linear. What's the formula for rotational kinetic energy? 1 half I omega squared, where I is the rotational inertia. And then translational kinetic energy is 1 half mv squared. So I is rotational inertia, sometimes called moment of inertia. And you have to know that for a solid sphere, it is 2 by 5 mr squared. Okay? So you have to know. If it's a hollow sphere, it'll be 2 by 3. Since it's solid here, it's 2 by 5. So half times 2 by 5 mr squared. And what is omega? Omega is v by r. Angular velocity is linear velocity by radius. So now that, because you're squaring it, it's v squared by r squared. Plus the other term you write as it is. And then in this term, you can cancel out so many terms. What can you cancel? The 2's gone, the r squareds are gone. So that gives 7 by 10 mv squared, because here you have 1 by 5 and then you have 1 by 2. So 1 by 5 plus 1 by 2 is 7 by 10. Yes. So 7 by 10 mv squared. You see that common there. So now we know whatever is given, the mass is 300 grams, so that's 0.3 kilogram. Velocity is 5, so that's 5 squared. Therefore, the total energy is 5.25 joules. All right, so you have to know it has both rotational kinetic energy and linear kinetic energy. Let's do a couple more in this part. A bullet, when fired into a target, loses half of its velocity after penetrating 20 centimeters. Further distance of penetration before it comes to rest is... So let's say you have a block of wood or something, wood, strong wood, hard wood. You fire a bullet into it. As the bullet goes through it, it'll slow down, right? Because the wood is going to apply an opposing force. So the problem says it loses half its velocity when it travels 20 centimeters. Now, how much more will it travel before it stops? Further distance of penetration before it stops. So we have to be careful here. It's always good to work in terms of energy. You know that initially the bullet had kinetic energy. When the velocity becomes half, because kinetic energy is 1 half mv squared, when the velocity becomes half, the kinetic energy becomes a quarter, 0.25. Velocity becomes 0.5, which is half, and kinetic energy becomes 0.25. So how much energy was lost? 0.75. Oh, I hope it's making sense. So if it started with 100% kinetic energy, it became 25%. So how much was lost? 75%. I think you got it now. So 0.75 was lost. All right, so let me write it. Now, I want to use this. Kinetic energy becomes 1 by 4 or 0.25. So what was lost is because the block of wood was doing work. So what is the work done by the block of wood? Same as the loss of kinetic energy. So work done is 0.75. Got it? How much ever was lost is the work done by the block of wood. And then you know for work, the formula is force times distance. So assuming that the force applied is F, the distance is 20 centimeter, which is 0.2. So you get F times 0.2 is 0.75. Now the second part. In the second part, the block of wood applies the same force, but we do not know how much it travels. So we'll take it as X. So F times X. But now how much is lost? Remember, it had 0.25 and then became 0. Because when it stopped, that means the loss was how much? 0.25. That means the work was 0.25. So F times X is 0.25. Now we have these two equations. It's just math. I just divided this equation by this. The F's will get cancelled. You will get X divided by 0.2 is equal to 0.25 by 0.75. 0.25 by 0.75 is 1 by 3. Check it out. It's 1 by 3. So when you cross multiply, you would get X is 0.2 by 3. 0.2 times 1 by 3, which is 0.0666 meter, which is 6.66 centimeters. So that's how you get that as the answer. Shall we do one more? Okay. Oh, this is a direct question in elastic collision without even looking at the choices. What is an elastic collision? It is one in which both momentum and kinetic energy are conserved. What is an inelastic collision? Where momentum is conserved, but kinetic energy is not conserved. So just remember, momentum is always conserved in a collision. If it's elastic, both are conserved. So the first one is the answer. None of the other choices make sense. Because B says neither momentum nor kinetic energy. Wrong. Only momentum is conserved. Wrong. Because kinetic energy is also conserved. D says only kinetic energy is conserved. Wrong. Forces involved in the interaction are non-conservative. That's wrong. Because forces involved are conservative. Like there is no force like friction here. Okay. So that's also wrong. So this is part 3. I'm trying to finish this in a record number of days. And what you got to do is you got to, like this, share, comment on it. It takes me at least 4 hours to do this. Although I know the subject, I still need to write it, make it a video, edit it, upload it. And as long as people are using it, I'm like, okay, all this time that I'm spending is worthwhile. So please, if you could share this video, comment on it, like it at least, then that would make me so happy. And other people would benefit. Thank you so much. And quite soon I'll be releasing part 4 of this entrance exam questions. Thank you. See you soon.